All right, we're doing 4.1, which is properties of quadratic function. Let's go over the basics. A quadratic function is basically when you have an equation. Okay, you've been working a lot with this part of it, and usually you've been making it equal to 0. The part that's new and changed and scary to you is the fact that now it's equal to y. This shouldn't be really scary to you and different. It should tell you it's going to be a graph. Previously, you've worked with linear relations, okay, stuff like this. You know how to graph this. You know it makes a straight line. You know it's going to look like that. Basically, same idea. By the end of this unit, you will be able to take a function that looks like this, and you will be able to graph it with great accuracy to look like that. It doesn't actually look like that, but that's the idea, okay? You're going to also find out that this is the worst form that you can write quadratic functions in, but you're going to learn how to change them later on, okay? Yeah. So, general form of quadratic functions is this. It's written this way. It's y equals ax squared plus bx plus c. This should be familiar because when you did quadratic formula, it was written this way too. This way is still great because quadratic formula, basically all that stuff you learned last unit about factoring and quadratic formula, super useful, super useful, essential for this unit. Okay, we'll get into how to use them. But in this form is called general form. What you are going to be working with, the basic parabola, the most basic, is y equals x squared. Okay, that is the basic quadratic function, and then it just gets more complicated when you add in other terms. Essentially, this is plus 0x plus 0. Okay, so this simplifies out and just becomes y equals x squared. I want to show you on like a beautiful graph what this looks like. I use Desmos, desmos.com. Okay, you can get the app on your phone and you can do this if you can't afford a graphing calculator or whatever. Obviously, you can't use it on a test to just give you the answers, but when you practice graphing your quadratic functions, you can actually see, did I graph it properly? So this basic graph, y equals x squared, okay, looks like this. Just to like give you a heads up, when you're typing on Desmos and most like written forms, when you want to write an exponent like squared, you have to press this button. Okay, for most keyboards, it's the Shift 6. Okay, so your key should look something like that. When you press Shift 6, it makes that button, and that's how you do exponents. Just so you know, so you can do this yourself. So this is the basic quadratic function you can see here. It curves, and I want to talk about what some of these basic points are on this graph. Okay, actually, let's make it look a little bit better. Cool, works for me. All right, we'll take a picture of this. Man, no. Cool. All right, let's put that in here so we can look at it. All right, it's not working. Okay, we'll do it this way. There's a couple key points on every parabola that you need to know about. This one right here at the bottom is called the vertex. These two are the x-intercepts. This is the y-intercept. And there's axis of symmetry goes right down the middle. Good, draw it again so we can actually see it and label it properly. Okay, our parabola looks something like this. First of all, it extends forever. And if you want to think about domain and range, okay, the domain is that it goes forever in both directions. So x is a set of real numbers. Okay, the range is that it goes up forever. It's a set of real numbers that as long as y is greater than or equal to whatever the vertex is. Okay, you also might get cases where it's less than or equal to if you have a parabola that goes like that. Okay, but it's all of these values, and it goes up forever, and it goes right forever, and it goes left forever. So let's label it. That point is the vertex. The way I remember it is it looks the most like a point, and a vertex is like, you know, when you have these vertices, right? Vertex. Okay, same idea. If you have a parabola like this, that's still your vertex. Okay, doesn't matter which way it opens. Through your vertex, if you drew a straight line, straight up and down, Okay, that would be your axis of symmetry. Axis of symmetry. Spelt wrong. Okay, axis of symmetry. The idea is that if you drew a line straight down the middle, it would be your mirror on both sides. This is actually an equation. It's x is equal to whatever. So in our case, if we flip back over to that graph, this was at 3. This is the x value 3. So this would be x equals 3. 3, okay, is the line that goes up and down and bisects the parabola. The vertex is a point. So for us, it has an xy coordinate of 3, -2. So this is going to be 3, -2. Cool. That's our vertex point. The other points we care about, these are the most important. These will be your entire life, are the x-intercepts. Okay, xints, x-intercepts. They're also called solutions. They're also called roots. They're all the same thing. Okay, they're those things. Those are almost always what you're trying to solve for. The last one's the y-intercept. This doesn't matter a lot of the times. There's a couple word problems where it's important, but usually it's not as important as the x-intercepts. Sometimes you got to find it. Yeah, that's the basic points on a parabola. Oh, if we wanted to label our x-intercepts, if we zoom in a little bit better, we can see here. Desmos is nice because if you click on it, it actually tells you exactly what the points are for the vertex, the x-intercepts, the vertex, the y-intercept. If we want it, we can click on it. Okay. So in this case, our x-intercepts are those numbers. It's probably a nicer fraction than the decimal that's rounded. Okay. Usually x-intercept you don't say as a point like 3, 0. Okay. You just say the x value because it's implied that the y value of an x-intercept is 0. Cool. What else do we want to talk about? Oh, how to graph these. All right. So if we're looking at this equation, you know what? Let's do one that was in the book to make it a little easier. We will do this one. Yeah, that'll do. Okay, y equals x squared plus x minus 6. Okay. If you wanted to graph this, the painful, awesome, cool way to graph it is you make a table of values. Okay, old school. You're going to put in your numbers, -2, -1, 0, 1, 2, and you're going to solve for the y's. You're going to do this by subbing these numbers in for x in both places. Be very careful about negatives and positives. I also strongly suggest that you have some negative values on both sides so that you can actually see a change. You might also have to go more than what you see until you get to the vertex, and I'll show you what that means in a minute. Okay? You're going to sub it in one at a time, painfully slowly, to see what happens as your pattern goes through. Okay? So I'm going to show you 1, okay? -2 squared plus -2 minus 6. -2 squared is 4, minus 2 minus 6. Okay, so it's going to be -4. So I'm going to put -4 in for my answer. Now I'm going to do it again, but instead of putting -2s, I'm going to put -1s into the equation. -1, -1. So it's 1 minus 1 minus 6 gives me -6. Cool. Now we're going to do it again. We're going to sub in 0. It stays the same. 0, 0, 0 is obviously -6, right? Do it again, subbing in 1s. 1 plus 1 minus 6 gives me -4. Okay? Do it again with 2. 2, 2. 4 plus 2 gives me 0, 0. Cool. Okay? So, just by doing this, I actually have enough information that I could graph it if I wanted to. Okay, on my terrible, terrible inaccurate graph. And we'll make this the axis. Okay, each of these is a point, just like when you did it with linear relations. It's just going to make a curve. Okay, so -2, -4. Gotta make one more line. Bam, first point right there. -1, -6. Even more points. Right there. Okay. 0, -6 is right there. 1, -4 right there. And 2, 0. There. Okay. As I can see, I have found an an x-intercept there. If I drew my mirror point, which you'll notice each point has like a mirror on the other side, my other x-intercept would be over here. Okay, cool. The other thing you'll notice is that there wasn't actually a lowest number. I can tell my lowest number is going to be in between these two, and it's pretty, because these two are the same, it's actually going to be at negative 0.5. If I sub that number in, I would find exactly what the vertex is going to be, and I would be able to find it there. Okay? I don't want you to worry. This is going away very soon. This is the slow way to do it. If you totally forget how to factor on your test, you could do this. It just takes forever, as you saw. Okay? We're going to learn cooler ways to graph it, but that's the basics so that you can make a basic parabola that looks like that. 5 points is required to make a parabola. Ideally, the vertex and then 4 other points. Okay? 3 points is kind of lame, not enough. That's how you graph it when you need to graph it. The other thing I want to show you is a cool pattern that comes up. I'm going to rewrite what I just had there. Okay, -2, -1, 0, 1, 2. And it was -4, -6, -6, -4, 0. I want to do a set for a sec. Y equals 2x plus 1. Okay, if I graph this, this would be 1, 3, 5, 7. Okay, from last year I have this value. Hopefully you remember finding first differences, which is trying to see how does the number change each time. So in this case it would be +2, +2, +2, +2, because every time it's increasing by 2. If these numbers are all the same, it means it's linear. Okay? What we're going to find here is that when we do quadratics, which is this, the curvy one, the first differences don't work, but there is something that does. So let's do the first differences. Okay? When we go from -4 to -6, we went down by 2. When we go from -6 to -6, we changed by 0. When we went from -6 to -4, we went by +2. And when we went to from -4 to 0, we went by +4. Do these have the same numbers? No. Therefore, it's not linear, which we knew already. But now we're going to do what's called second differences. Okay? We're going to do the differences of the differences. So when I look at this, -2 to 0, that was +2. From 0 to +2, that was +2. From +2 to +4, that's +2 as well. If these are all the same, that means there's going to be quadratic. It's kind of cool. The idea is that if you have an equation like this, the degree is 1, okay? Because there's a 1 exponent on this. And the first differences were all the same. Sorry, were all the same here. In this equation, we had, it was over here, right? Y equals x squared plus x minus 6. In this equation, the degree was 2 because there was a 2 exponent. That's why the second differences were all the same. If you had an equation, you're not going to get this. If you had an equation like this, the third differences, these ones that are here, would be all the same. Okay? So, if you ever have a table of values and it says, is this quadratic? You need to check the second differences and see if they're all the same. The cheater way to tell if an equation is quadratic is to look at the equation for the exponent. Okay? So if I have y equals x squared plus x minus 5, let's put a number there, a different number. Okay? I know this is quadratic because there's x squared. If I have this, I know this is quadratic. It looks weird. It has x squared. It's going to be a parabola. Okay? It's actually going to be this kind of parabola. Yeah, that's how you can tell. There's one more thing I want to cover in the video. What was that? Was that in this section? Yeah, it was. All right, the discriminant. So, discriminant, you remember when you wrote the quadratic formula. Okay? Negative b plus minus square root b squared minus 4ac over 2a. The discriminant was just this part. Okay? The discriminant is still useful because we're still doing this based on our general form equation. Okay? So we had x squared plus x minus 6 was our equation, right? Right? Yeah, it was. Okay? If we looked at the discriminant of this equation, okay? Remember, this is a, this is b, this is c. So this is 1, 1, 6, negative 6. Let's look at the discriminant. B squared minus 4ac. So b squared, 1 squared minus 4, 1, negative 6. So that's going to give me 1 plus 24, so it's 25, root 25, okay? Or just 25. You're going to see a cool pattern. There's 3 types of answers, which we talked about last unit with discriminant. You could get ones where you have the square root of a negative number, okay? When you did that, there's no solutions. You had discriminants where you had like a big number, I don't know, 100, doesn't matter, okay? Something positive, that gave you 2 solutions. Because remember, that was that plus minus stuff. Okay. The third option was when you had square root 0, that gave you 1 solution. Because there was no plus minus, because it was 0, you cancel out. The same thing is true with parabolas. What we're dealing with is when we graph parabolas, our solutions are the x-intercepts. So when we did the one we just did, it was positive. And if we looked at that graph that we did, it had 2 x-intercepts, okay, those yellow ones. Whenever you have a discriminant that is a positive number, there's 2 solutions, or 2 x-intercepts. If you did it with a negative number and there's no solutions, it means your parabola looks like this. Or it means your parabola looks like this, or this, or this. Because it's not actually going to cross the x-intercept. You can graph it, it just doesn't have x-intercepts. Okay, well, let's do that. The third one, the green one, there's only 1 solution. These ones are kind of weird to think about, but it basically means that your vertex is on, that was terrible. There we go, is on the x-axis. So that is your vertex. That is your vertex and your x-intercept at the same time. Okay, it can be this, it can look like this too, it doesn't matter. It just touches, oh my gosh, I cannot draw. It just touches at one spot. Okay, that was a lot of information. I think the most important thing is A, when you have a parabola, where was it? Here. When you have a parabola, being able to talk about the different points. You need to know those because you're going to be talking about these 3 all day, every day. The other big thing you need to know is, really quickly, if it has a exponent, it's quadratic. Exponent of 2, it's quadratic. You should be able to graph using a table of values, but that becomes obsolete soon. And then this thing, the idea of like, look at the discriminant, and I know how many solutions or how many x-intercepts it's going to have. Okay, those are the big concepts that we learned. 4.2 is just a lab, so it's not as hard.